So in the previous first lecture, actually, we have seen that how do we define order of a differential equation. What do we mean by order of a differential equation? Order of a differential is
So by degree, so the degree of,
degree of d.
yes,
Okay, so whatever number of highest number of derivatives you take in a differential equation is actually the order of differential equation. So we will be using variation of parameters, particularly when our differential linear differential equation is of order 2. And I will write down a order 2 differential equation, say a into d2y by dx square plus b into dy by dx plus c into y is equal to f of x. So you can see that there are highest number of derivatives of y, those are taken in this differential equation is 2, and that's why this is order 2 linear differential equation. Order 2 linear differential equation with constant coefficient. A, B, C are constant. Okay. So now what will be the auxiliary equation for this? Auxiliary equation will be, anyone?
sir, b square plus d plus um, so d square plus d into y is equals to 0. Not into y, that will be is equal to 0.
What about this ABC? So we have A into d square plus B into d plus c equal to 0. So we have this auxiliary equation, and in auxiliary equation we know that d by dx you put as capital D and you solve it. And now we will find out the roots. So how many roots I'm going to get here? For this auxiliary equation, how many roots we will get? Maximum number of roots that we can get here.
So 2.
2. So since the polynomial is of degree 2, we are going to get 2 roots. Okay. So since for this linear differential equation, I'll get 2 distinct roots. What types they can be? Say if the roots are m1 and m2, or else there can be m comma m. And in the third case, I'll get complex roots a plus minus ib. So since this is a polynomial of degree 2, what will happen here is I'll get 2 roots, of course. So what can be the nature of those roots? So these roots are real and distinct. These are real and repeated. And the third one, complex. So what do we have? Yc is equal to, what will be the solution? Anyone? In the first case, what will be the solution here? Yc is equal to, what the case for real and distinct? C1 e to the power m1x plus C2 e to the power m2x. The second one, the roots are real and repeated. So in this case, Yc is C1 plus C2x e to the power mx. Third one, Yc will be equal to C1 cos bx plus C2 sin bx e to the power ax. Okay, this type of solutions you will get in all the three cases. So the idea behind the variation of parameters is, I will call, I mean, when you have degree 2, you will get two independent solutions. So जो भी constant के साथ है, the first constant you will have the first solution y1. With the second constant, we will have solution y2. Now open the bracket. This I can write as c1 e to the power mx plus c2 in bracket x e to the power mx. Okay. So first constant के साथ है e to the power mx. With the second one I have x e to the power mx. So y1 is equal to e to the power mx. Y2 is equal to x e to the power mx. The third one, if you open the bracket, what will be y1 in this case? Anyone?
Sir, cos bx.
Just cos bx, open the bracket and then tell me.
Cos bx plus sin bx.
Open the bracket. With the first constant, whatever is there, that is your y1. With the second constant, whatever things are there, that is your y2. So my question is, open the bracket, tell me what is y1.
Sir, cos bx into e raised to the power ax.
Yes. So when we open the bracket, what we get is y1 is equal to e to the power ax sine of cos of bx. Sorry, cos of bx. What is y2? E to the power ax sine of bx. Okay. So what do we observe here? What I really want to emphasize is, no matter what is our auxiliary solution, I can always find out y1 and y2. In variation of parameter, this y1 and y2 plays a major role. Okay. What do we assume is, in variation of parameters, we assume that, so I will write it down a small note over here. In variation of parameters, we assume my yp is combination of y1 and y2. Yp is equal to u into y1 plus v into y2. Okay. So in shortcut method, how do you find out yp? You send that phi of d on the other side. Whereas when I am dealing with variation of parameters, I assume that my particular solution yp is actually the combination of y1 and y2. So u times y1 plus v times y2. So in variation of parameter, task is our task is to find u and v. To find u and v. So once you get u and v, what we will do is we'll put that here, and that is my particular solution. Okay. So there are defined formulas to find out u and v. Of course, there is a lot of theory part there, but I am not going into details of the theory part. In this method, the u is given by u is equal to this things you have to memorize it by heart, minus y2 into f of x divided by w, and v is given by integral y1 into f of x upon w into d, where w is equal to the determinant y1, y2, y1 dash, y2 dash. Can anyone tell me what is this y1 dash and y2 dash?
So inverse.
Those are inverse. Let me check how. Miss Chandratej? So we started with the two differential equation. We write down the auxiliary equation. We write down the solution yc. From yc we get y1 and y2. And for particular solution by variation of parameter, we assume that my particular solution is of this type. In this, u is given by this formula, v is given by this formula, and w is this. Now my question is, when I write y1 and y2 here in the first row, what is y1 dash and y2 dash? Yes, Samarji, tell me what is y1 dash and y2 dash?
Sir, can't say 1 upon y1.
Shainesh, Samarji,
Yes, sir.
uh, okay, sorry. Yes, yes, Indore. Okay, so these y1 dash and y2 dash are going on a right track. Actually, this is the derivative of y1, derivative of y1, and this y2 dash is the derivative of y2. So this is the complete procedure. Okay, so to solve any of the example by variation of parameters, this is the complete procedure. What you do is you find out yc. From yc you declare y1 and y2. Then for particular solution, let's assume that my solution is of this type. Then use these formulas to find out u and v. Okay, I hope everything is clear now. Once you are clear, so I can go to the solution. Example. Solve. This type of statement will always be there. I mean, the question will be solved by variation of parameter always. And if it is not, you should be able to identify key which is better for me. Either shortcut method is good, or variation of parameter is good, or general. That could be a good exercise, that in which cases you will go for variation of parameter, or in which cases you will go for the shortcut method. So you can think over it, and that will help you. D square plus 4 y is equal to sec 2x. Okay. This is the differential equation we need to solve by variation of parameters. First of all, write down the auxiliary equation. The auxiliary equation is d square plus 4 equal to 0. So you can do this using your scientific calculator. If you are good enough, you can do it using your quadratic formula, and the roots are plus minus 2i. So depending on this root, the auxiliary solution is yc is equal to anyone. Yc is equal to
Sir, C1 cos 2x plus C2 sin 2x
e to the power
e to the power ax would be x.
0. E to the power 0 is 1. So I've got the auxiliary solution. Okay. Now we need to go for particular solution. What is our y1 from this? Whatever is with the first constant, that is your y1. So that is cos of 2x. What is with the second constant? Sin of 2x. By variation of parameters, by variation of parameters, yp is equal to u times y1 plus v times y2. So yp will be equal to u times cos of 2x plus v times sin of 2x. Now what is our task? Our task is to find out u and v. For u and v, we have the formula, but in that formula we need w. What is w? W is equal to the determinant y1, y2, y1 dash, y2 dash. What is this actually equal to? Cos 2x sin 2x. Derivative of cos 2x is minus 2 sin 2x plus 2 cos of 2x. How do we take the determinant? You do the multiplication. This to this, and subtraction. So we'll have 2 cos square 2x minus this into this is minus 2 sin square 2x. So when we open the bracket, minus minus will become plus 2 in bracket cos square 2x plus sin square 2x. So cos square plus sin square is 1. So w is equal to 2. Now, once we get w, immediately go to find out u. U is equal to minus integration. What is our y2? Y2 is sin 2x into f of x. What is f of x? F of x is the right hand side. What is our right hand side here? Sec 2x. So sin 2x into sec 2x divided by w. W is 2 dx. So once we solve this, we'll get the answer. This is minus integration. Sec 2x is 1 upon what is sec theta equal to?
So for sec 1 upon
1 upon what is equal to sec theta?
Cos, sir, cos.
1 upon cos 2. Okay, so sine upon cos will become tan, minus 1 by 2 being constant will come outside, integration of tan 2x dx. The integration of tan theta, log of sec 2x divided by 2. So minus sign will go inside and we'll have 1 by 4 log of cos 2x. This is u. 1 by 4 log of cos 2x. Similarly, use the above formula what we studied to find out v. The formula for v is equal to integration y1 is cos 2x, it is our f of x, that is sec 2x, as our w is 2 dx. Just now we have seen that sec 2x is 1 upon cos 2x, so this 2 will get cancelled out and the answer is 1. So this is 1 by 2 will come outside, integration of dx. So this gives me v is equal to the integration of dx is x. This is here v. So we have got u, we have got v. We just have to place it in the formula. So yp is equal to, what is the value of u? U is equal to 1 by 4 log of cos 2x. 1 by 4 log of cos 2x plus into cos of 2x. This is y1. This is your u plus 1 by 2 into x. This is our v. That is our y2 sine 2. This is your y2. So combined after putting the values, this is a particular solution. And hence, our solution of differential equation y will be equal to yc plus yp. Y is equal to c1 cos 2x plus c2 sine 2x. After we complete the auxiliary solution, write in the particular solution, which is 1 by 4 log of cos 2x into cos of 2x into cos of 2x plus x by 2 sine of 2x. Any difficulties, please ask, or I'll go to the next example. clear? I'll go to the next example, example number 2. Solve. Just a minute, this is not working properly. Not able to write it. Let's go to a regular method. Okay, so example number, is the screen visible?
Yes, sir.
Okay, so example number 2, solve by variation of parameter d square minus 60 plus 9 y is equal to e to the power 3x upon x square. Okay, so for variation of parameter, first of all, auxiliary equation d square minus 60 plus 9 equal to 0. To the values of d, this gives me d is equal to 3 comma 3. You can check it using your scientific calculator. So yc will be equal to c1 plus c2x e to the power 3x. So let y variation of parameters yp is equal to u into y1 plus v into y2, where y1 is, anyone, what is y1? Who can tell me the values of y1 and y2 here?
So y1 is c into e raised to the power 3x.
C लेना है क्या?
No, sir. Only e raised to the power 3x.
E to the power 3x and y2.
So y2 will be the same. x3 e raised to the power 3x.
X into e to the power 3. Okay. So once we get y1 and y2, we need to find u and v. But for u and v, we need w. W is called the Wronskian. e to the power 3x, which is y1, x e to the power 3x. And the derivative of e to the power 3x is 3 e to the power 3x, and derivative of x e to the power 3x. D by dx, I'll find it out here, x e to the power 3x. So this is equal to, by product rule, x derivative of e to the power 3x is 3 e to the power 3x plus e to the power 3x, that is x plus 1 e to the power 3x. Oh, sorry, 3x plus 1. So I will write it down here, 3x plus 1 e to the power 3x. Let's find out the determinant for this. Do the cross multiplication and subtract. So this is e to the power 6x in bracket 3x plus 1 minus e to the power 6x in bracket 3. Take e to the power 6x common, 3x minus 3x will get cancelled out, remaining will be 1. So from this, Wronskian is equal to e to the power 6x. Now find out u. Now u is equal to minus integration y2. What is y2? X e to the power 3x into f of x. What is f of x? F of x is the right hand side, e to the power 3x upon x square, and total divided by the Wronskian e to the power 6x d. So this 2 after multiplication will become e to the power 6x. So this gets cancelled out. 1x will get cancelled out. So what do we have is minus integration 1 upon x dx. So integration 1 upon x is minus log x. Now let's find out v. V is equal to integration y2. What is y1? Y1 is e to the power 3x into the right hand side, e to the power 3x upon x square, and divided by e to the power 6x, the value of w dx. Again 6x will get cancelled out. What we have is integration 1 upon x square dx. Anyone can tell me what is integration of 1 upon x square? Give you a hint, x raised to minus 2 dx. Now can you tell me what is the answer?
Minus 2
Minus
x minus 2 x. नहीं sorry, minus 2 x raised to minus 3 ऐसा है शायद.
have you downloaded the list for integrations, formulas of integration and derivatives? If not, do it today so that you won't get confused. What you are telling me is actually the derivative. We are not finding out the derivative. For integration, the formula is x raised to minus 2 plus 1 upon minus 2 plus 1. So that is going to be minus 1 by x. This is your u. This is your v. And hence yp, I will write it down in the top corner. Yp is equal to minus log x into e to the power 3x. U into y1 plus v is minus 1 by x into y2, x e to the power 3. This is yp. And so your final solution y will be equal to yc plus yp. Make sure that you need to write down the final solution. It has 1 mark. If you are fortunate enough to give theory exam, then you have to complete it up to yc plus yp. So I hope the complete method is clear to you and you'll be able to solve one example on this. So let's see who can do it.
सर हाउ इन दैट इक्वेशन सर दैट y का वो सर x into वो e raised to x आया था सर सर वो इक्वेशन में वो y2 का इक्वेशन है मतलब y2 का वो x into x raised to 3x के e raised to 3x कैसे आया सर
पहले तुम लेट क्यों आए ये बताओ।
सर वो नेटवर्क का प्रॉब्लम था सर
अच्छा आधा पौन घंटा।
हाँ सर वो मैं 4:11 को आया था सर वो लाइट भी नहीं थी सर और नेटवर्क का बहुत प्रॉब्लम था सर
ठीक है हाँ अब बोलो प्रॉब्लम क्या है।
सर वो y2 का इक्वेशन x into e raised to 3x कैसे आया सर
ये ब्रैकेट ओपन you have opened the bracket here. You have got yc from yc जो फर्स्ट कांस्टेंट के साथ जो कुछ भी होगा that is your y1 and whatever is with the second constant that is your y2. So if I open the bracket here I'll get c1 e to the power 3x plus c2 x into e to the power 3। तो जो फर्स्ट कांस्टेंट होता है उसके साथ में जो है दैट इज योर y1 whatever is the second constant things associated with second constant which is y2. So in every time you will have to do this. Open the bracket and whatever is the first constant declare it y1, whatever is the second constant declare it y2. Fine.
yes sir
So I'll just write it down here. In variation of parameter yp is u into y1 plus v into y2, where u is equal to minus integration of y2 into f of x divided by w. V is equal to integration y1 into f of x divided by w, and w is given by y1, y2, y1 dash, y2 dash. Okay, so this is the crux of whole variation of parameters method. So I have enlisted it here because I'm going to give you one example which you will have to solve in next 5 minutes. Solve by variation of parameters, and the equation is d2y by dx square minus 2 times dy by dx is equal to e to the power x sine. Start solving it. First of all, write down the auxiliary equation. Tell me the roots. What is the auxiliary equation?
So d square minus 2d is equals to 0.
D square minus 2d equal to 0. So the values of d are 0, comma
2.
2. So yc is equal to, so roots are real and distinct. So yc will become c1 e to the power 0x plus c2 e to the power 2x. So by variation of parameter, assume that yp is equal to u times y1 plus v times y2, where y1 is equal to comma y2 equal to, what is y1?
E raised to 0x y1.
What is e raised to 0x is
1.
1. Y2 is e to the power 2. Find w, 1 e to the power 2x. What is the derivative of 1? Derivative of 1 is
0.
1x.
बेटा समझिए मत करो ऐसे ना.
Oh, yes, sorry.
Derivative of e to the power 2x is 2 e to
0.
the power 2x. So when you find out the determinant of this, that will be 2 e to the power 2x. Now you go for u. Use the formula for u. What is the formula for u? In minus integration y2 e to the power 2x into y2 into right hand side. Right hand side is e to the power x into sin x divided by w. W is e to the power 2x. So this 2 will get cancelled out. So this is equal to minus integration e to the power x sin x dx 1 by 2 outside. How do you integrate this? We apply the Liat rule. L-I-A-T-E. L means logarithm, not there. I is inverse, not there. A is algebraic, not there. T is trigonometry. So this is your U, this is your V. Apply UV rule of integration over here, minus 1 by 2 in bracket. What we will have is U, just sin x, integration of V, just e to the power x, minus integration, derivative of U is cos x, and integration of V, just sin x. D. Oh, what I've done something wrong. U integration of V minus integration derivative of U, and integration of V is e to the power x. Integration of V is e to the power x. Okay, so I'm calling this I. Okay, so I'll solve it somewhere else and I'll come back here. Okay. Integration has become a bit lengthy. Integration e to the power x sin x dx. I'm calling it I. So what we did was u integration of v minus integration derivative of u, which has become cos x integration of v e to the power x dx. Okay, we have came up to this. Now I'll go ahead e to the power x sin x minus, again we will have to apply uv rule over here. U is going to be cos x, cos x integration of v, so e to the power x minus integration derivative of u, derivative of cos x will become minus sin x, minus sin x integration of v to the power x dx. Okay, so once
Excuse me, sir.
सर तुमचा आवाज नाही येत.
Sir, you have muted yourself.
सर आवाज नाही येत. हॅलो सर.
आता येतोय का?
हा सर आता येतोय.
Okay. So whatever integration we have done on the previous page, that answer directly I have substituted over here. Now I'll go for v. The formula for v is integration. Now I will have to take y1 is 1, right hand side e to the power x sin x upon y1 into f of x divided by w, which is 2 e to the power 2x. So that will be 1 by 2 integral e to the power minus x sin dx. Okay. So again, this you will have to solve by the previous method and see what do you get, and that will be our final solution. I won't go for it now. Just one, you follow the steps what we have done for this, and surely you will get the answer over here too. Okay, so I think so the answer for this has to be a is minus 1. There's a standard formula for this. Probably you'll see that formula in Fourier series. Fourier transformation is there. So the formula is e to the power minus x upon a square plus b square minus 1 square plus 1 square in bracket a sine x minus b cos x. So I think so this will be the solution for this, and that you can put in yp and that will be the solution. Okay. I'll give you that formula too. How do you get the answer directly for the integrations with e to the power ax, sine bx, and cos bx? Fine. Uh, you want to write it down? I'll give you 2 minutes, and then I will give you one homework that you try, so that you will have a bit of practice with this.
So can you show the calculations of I?
The same procedure is to be done when for the second one, the values of v. Fine. I'll immediately write down one homework over here. So you try this homework. I'll also give you the final solution with this. d2y by dx square plus y is equal to tan x, solved by variation of parameters. And the solution for this is a cos x plus b sine x minus cos of x log of sec x plus tan x. See if you can get this. This is the value of y. This you should get. Try this by variation of parameters. In this case, 100% the integrations are not going to be that difficult. You will be able to do it. The first one and the second one is y double dash plus y is equal to sec x. And the solution for this is a cos x plus b sin x plus x sin x plus cos x log of cos x. The final solution. Try this and see if you can get it. In the next two lectures, we'll end our first module and we'll go for the second module. As soon as we complete the first module, we will have a test of 15 marks. Please start preparing for the same. Okay, just put your name and roll number in the chat box. Okay, stop here. Thank you everyone.